Hello, ladies and gentlemen. Today I'm going to talk to you about bike fit variables. Two aspects specifically. I'm going to talk to you about pedal design and saddle height. In a study done by Hespel et al., they looked at a novel pedal design compared to a conventional pedal design. In this novel pedal design, you can see that there's a forward and downward angle where the cleat goes in compared to the conventional pedal design. This novel pedal design was able to create more power output compared to this conventional pedal design. Why, you may ask? Well, simply because it increases the lever arm. And by increasing the lever arm, you have more torque and therefore more power. In another study, or in a peer-reviewed article by Binney et al., they looked at saddle height. And saddle height really creates a lot of different questions for us. If we look at injury rates, power output, comfort level especially, they asked a lot of questions about what can happen when changing your saddle height. And more specifically, they found that if you change your saddle height by just 5%, you can change the kinematics of the lower limb by an astounding 35%. So this is something that really needs to be taken seriously. In a study done by Fonda et al., they looked at adjusting a cycle when going uphill compared to cycling on level ground. They found that when cycling at a 20% gradient, if they adjusted their saddle by 20%, they gained more comfort and better performance. And this was shown by increased and better recruitment of EMG activity in the lower limbs. In a study done by Frintz et al., they looked at saddle position at 109% of the inner leg length. This is an optimal leg length. This is an optimal saddle height to create the best seat, to create best optimal kinematics. Now, they experimented by adjusting the leg length by going lower and higher. And what they found that as the lower they went, the worse the kinematics became. What happened was the ankle took over more and the knees started to take on more stress as well. So you really don't want to go below 109% of your inner leg length, or your performance and injury rate may suffer and increase respectively. Now, another study done by Binney et al. Looked at the effects of saddle height, pedaling, workload on joint kinematics and kinetics during cycling. When they increased the saddle height, they found that the ankle work, which may decrease, when they increased the saddle height, and this is kind of going with the Frintz study, that found that increasing the saddle height increases the ankle work and therefore decreases the amount of force done on the knee. Now, this is optimal as 50% of overuse injuries in cycling is due to the knee. And the knee takes on a lot of forces when cycling. So we can reduce those forces by transferring most of the force to, or at least some of the force to the ankle. We're able to save our knees from a lot of wear and tear over time and optimally be able to cycle for longer. So thank you for listening and tuning in. Next week I'm going to talk to you about aerodynamics.